Hi everybody, in this video we're going to go over the review sheet for test number 2. So in the first question it says which statement justifies this construction. So that is the first one. Measure of angle 1 is equal to the measure of angle 2. And that's because in this picture those two angles are corresponding angles. And we talked about in class how showing that corresponding angles are congruent is one way of showing that lines are parallel. If corresponding angles are congruent, then that means the two lines are in fact parallel to each other. That's not the only way to create parallel lines, but that's the way that we did in class, creating congruent corresponding angles to make lines parallel. But once again, that is not the only way. Remember, any angle relationship that is true when lines are parallel could also be used to prove the lines parallel. For example, showing that alternate interior angles are congruent could also prove the lines parallel. Showing that same side interior angles are supplementary could also prove the lines parallel. Here, we just have corresponding angles, but that does in fact make these lines parallel to each other. In number 2, we need to find the number of degrees in the acute angle formed by the intersection of Walnut Street and Elm Street. So here's where Walnut Street and Elm Street intersect. So up here would be the obtuse angle. Here would be the acute angle. So this is the angle that we're trying to find the measure of. So I'm going to take a look at the two expressions that they give us, and I'm going to see what the relationship is between them. So here, and let me just erase this other stuff here so we can see what I'm talking about here. So here, we have two lines cut by a transversal. And if you take a look, we see a letter Z. In the corners of the letter Z are alternate interior angles. And you can think of these angles as being inside the lines on different sides of the transversal. This one's to the right of the transversal, this is to the left of the transversal. But if you see a Z, either backward Z or forward Z, that would be alternate interior angles. So here we have a Z, that's alternate interior angles. And these are streets, and it does say that they are parallel to each other. So I'm going to put that in the diagram. And since we do know that we have parallel lines, we know that the alternate interior angles are congruent. So we know that the two angle measurements are equal to each other. So that would be 33 is equal to 3x. I just subtracted 2x on both sides. And then I'm going to add 15 to both sides. That is 48 is equal to 3x. And then to get x by itself, I'm going to divide by 3. And I have x is equal to 16. That's not the answer because you need the angle measurement, so you do need to plug back in. You can plug in for either angle because they are congruent alternate interior angles. They should have the same measurement. So 16 times 2 is 32. 32 plus 33 is 65. And it makes sense because it is an acute angle, so the measurement should be less than 90 degrees. So the final answer, the angle that we're looking for, is 65 degrees. Okay, moving along. So whenever you're approaching any proof-like question that gives you some given information and you have to draw a conclusion, always start by taking a look at your givens, marking your diagram with your givens, and thinking, how can I reach my goal? What conclusions can I draw that can help me to reach my goal? So I'm going to do that before I even go to the multiple choice question. And this is the steps that you need to be taking. These are the steps that you need to be taking anytime you're approaching a question of this sort. So we're given that AC is congruent to ED. Sorry about the weird symbols. I didn't know how to type the congruent symbol, and I couldn't get the line segment symbols because that was really difficult to type. But AC is congruent to ED. I'm going to mark those congruent segments in my diagram. And my goal is to show that AD is congruent to EC. Now, I'm going to think about how can I get from AC to AD? How can I get from ED to EC? Because I'm going from AC to AD and from ED to EC. And I'm going to think about, am I changing the size of the segments? And the answer is yes. Am I making them bigger or smaller? And the answer is bigger. So since I'm going from a smaller segment AC to a larger segment AD, and from a smaller segment ED to a larger segment EC, I'm thinking I'm going to need to use addition. So I'm going to already eliminate answer choices 2 and 4 because we are not making it anything smaller, we're making it bigger. So this is definitely going to be an example of the addition postulate. Now, before we go choosing an answer, let's actually write out the addition and let's see which answer choice we think it is. So I'm starting with AC and ED. I want to arrive at the conclusion that AD is congruent to EC. Let's think about what we need to add on to AC to make the whole segment AD. If we're starting with AC, what we need to add on is CD to make the whole segment AD. That was supposed to be a line. Let me make that a little bit better. A mark, a congruence mark. So once again, if we start with AC and we add on CD, we make the whole segment AD. Let's think about what we need to add on to ED to make EC. To ED, we need to add DC or CD. Same thing, same 2 letters. So keep in mind, in order for our addition to work, we have to be starting with 2 congruent segments and adding on 2 congruent segments. We know that AC is congruent to ED because that was given to us. I'm going to put a check mark. That was given to us. It's not given to us that CD is congruent to DC. Oh, and I forgot to mark it in the diagram. There we go. Usually when something is the same as itself, we do mark it with an X in the diagram. So you might be thinking, well, CD and DC are the same segment. They're the same 2 letters, they're the same line segment. So they have to be the same as itself. It has to be congruent to itself, and you're absolutely right. But since it's not given, that's a conclusion that we're drawing. So before we can do this addition, we do need to state, and I'll just put it up here to indicate that it has to come before the addition, that CD is congruent to itself. You can write DC as CD if it makes it easier to see that it's the same segment, but CD and DC are naming the exact same line segment. And if we think about how we can justify this, what postulate says or property says that anything is congruent to itself? That would be the reflexive property or postulate. So from our addition, to get our conclusion, we do need to know that the 2 things we're adding on are congruent, and CD is congruent to itself due to the reflexive property. So that is number 1. So in total, if we were writing this out in a 2-column statement reason chart, there would be 4 steps in our proof. And I actually do want you guys to see this, so I'm going to write it out here. So if I'm making a 2-column statement reason chart, the first step would be my given information. Then before I could do my addition, I do need to state that CD is congruent to itself by the reflexive property. That has to come before the addition, because in order for the addition to work, you do need to know that the 2 segments that you're adding on to the congruent segments are also congruent. So that does need to come before your addition to make it possible. And then we can use our addition. We can do our AC plus our CD is congruent to our ED plus our DC, like we wrote up here. And that would be the addition postulate of congruence. And then finally, we always end a proof with what we're trying to prove, which is that AD is congruent to EC. And if you think about how we're getting from step 3 to step 4, we're saying this plus this is this. AC plus CD is AD. We're saying this plus this is this. ED plus DC is EC. So we're simply replacing the addition with what it actually is. We are substituting the addition for what it leaves us over with, and that is substitution. And usually, substitution always follows either the addition or subtraction postulate because we're replacing the addition or the subtraction with what it's actually giving us, with what our actual goal is. So substitution, as a general rule, always follows the addition or subtraction postulate. So that's how it would look like written up in the 2-column proof, which I do think is important to see, especially as we move into more proofs, as we get further on in the semester in geometry, which will eventually turn to completely proofs in the class. So it is important that we do see this. Number 4, based on the diagram, which statement is true? Is A parallel to B? I don't know. I think I need some more angle measurements. I don't even know what's going on here right now. What I am seeing, it's my favorite thing, vertical angles. I love seeing the letter X because then I see vertical angles. Vertical angles are always congruent, no matter if lines are parallel or not. So I don't have to know if lines are parallel to fill in vertical angle measurements. So I know that's 120 and that's 120 because they're vertical angles. I know 60 and 60. And once again, I'm just looking for the letter X. Intersecting lines form congruent vertical angles. And remember, vertical angles are non-adjacent angles. Anytime you have intersecting lines, the non-adjacent angles that are opposite from each other are congruent vertical angles. I think having all those markings made it more confusing. I'll just leave it like that. Okay, so 60, 60 vertical angles, 115, 115, vertical angles, 110, 110, vertical angles. I have a lot more stuff here. We're looking at A and B, and I have enough information now. I'm just going to highlight A and B for a second. And between A and B, I have these two angle measurements, and I know that those are same side interior angles. They're inside the lines, and they're both to the left of the transversal. They're both on the same side of the transversal. And I know that if lines are parallel, same side interior angles are supplementary. But here, those same side interior angles, 110 plus 60, make 170 degrees. So they're not supplementary to each other. So A and B are not parallel to each other. Once again, I know from the diagram, it looks like they are not parallel to each other, but do not trust diagrams. They are never drawn to scale. They are always drawn a certain way to make it look like something, and then that doesn't actually happen. But in this case, what we expected is true. A and B are not parallel. The same side interior angles are not supplementary. And of course, you can fill in more angle measurements using the supplementary angle relationships. The angles right next to each other form a linear pair and are supplementary. For example, this is 110, so that would be 70. This is 110, that would be 70. So you can use that to fill in more angle measurements. And then you can use a different angle relationship. But I already had the same side interior angles here without filling in anything more. So I just used those to draw my conclusion that the lines were not parallel. Okay, A parallel to C. So I'm looking at A and C. And it's a weird looking Z, but I do have a Z there. Inside the lines on different sides of the transversal. That's alternate interior angles. And if alternate interior angles are congruent, lines are parallel. But here, clearly, the alternate interior angles are not congruent. We have 110 and 115. Those are not the same as each other. So that's not it. Okay. B parallel to C. Let's check that one out. And once again, I already have same side interior angles without filling anything extra in inside the lines on the same side of the transversal. So let me add 115 plus 60 on my calculator, and that's 175. That's not supplementary. 180 would be supplementary. Oops. Let me go back to where I was. Oh no. Why is everything jumping around here? That's okay. I'll just erase this and rewrite it. So that was 60. So that's not the correct answer choice. Same side interior angles are not supplementary. And then finally, D is parallel to E. You might have been thinking this from the way the diagram looks, but once again, do not trust diagrams. And here we have another set of same side interior angles inside the lines on the same side of the transversal. Let me add these ones together, 60 and 120, and that clearly is 180. So I'm picking answer choice number 4, and my reason is going to be if same side interior angles are supplementary, lines are parallel. And that's not the only justification. It depends on how many angle measurements you filled in. You could have filled in more than I did. I filled in the bare minimum of angle measurements here. And if you filled in more angles, then you could have used other angle relationships. You could have potentially used alternate interior angles here to show the lines are parallel, or alternate exterior angles here, or even corresponding angles. It depends on how many angle measurements you filled in and which ones you focused on in order to accomplish your goal. Okay, moving on. Question 5 is just telling us to mark the diagram. So label the congruent segments and angles in the following diagram. So AB is congruent to AD. All done. BE is congruent to ED. Make it look different than BA and AD because they're not all congruent to each other. All done. EC is congruent to DC. All done. Angle BCA, so that's this angle right here, is congruent to angle DCA, so that's this angle right here. Remember, if the middle letter is C, it's going to be at C. All done. Angle AED is congruent to angle BEA. Be careful, do not conclude that these are right angles. It does not anywhere say that these are perpendicular. I cannot draw that conclusion, even though it looks like it. Do not mark those as right angles unless you have a reason to believe that. And finally, angle CDE, that's this one right over here. Oh, and I should be making these all look different from each other. I would have got some points off there. There we go. Is congruent to angle EBC. This one over here. These are congruent. They should have the same mark on them. Once again, it doesn't matter what marks you make. If you make them look like this or like this with the line sticking up from them, it doesn't matter. As long as I can tell, and you can tell, which ones are congruent to each other. And that it's not misleading and it doesn't make you think that they're all congruent to everything when they're not. Okay, we're going to make a parallel line construction through point P. It doesn't matter if your point is on or off the line. First step is always the same. We're going to make a transversal passing through point P. You really should make your transversal slanted. You could make it a vertical line, but it's going to make your construction really difficult. So remember, we're going to be copying an angle to up here to create congruent corresponding angles in order to do this construction. The first step is we're going to put the compass. Let me move up a little bit here on my page. We're going to put the compass on the vertex of the angle that we're copying. That's point P. I'm going to swing an arc. Oops. It doesn't matter the distance. It just needs to be on the angle. There we go. Oops, I misread the question. I'm always making mistakes. There we go. It's a perpendicular line. Ignore what I just did. We're going to backtrack. I was wondering why the point was on the line. I was like, wait, this is a little hard to do when the point is on the line. Yes, this is a perpendicular line. My bad. So we're making a perpendicular line through point P. Big difference there. Perpendicular and parallel are not the same thing. I'm going to put my compass on point P. It doesn't matter how far you open up. You just need to swing an arc that's going to hit the line in 2 spots. So here I hit my line in, why won't it let me write on it? Try this again. Let's move my compass and then let's see if it lets me. There we go. Those 2 spots. And then all I'm going to do is take my compass over to each of those spots. I'm going to just open up a little bit more, but the exact measurement does not matter. And I'm going to swing an arc. And then using the same measurement, I'm going to go over to the other intersection point and I'm going to swing the same arc. That's the whole construction. Right through here is where I'm going to use my straight edge, right through that intersection point, and I'm going to make my perpendicular line. And it should come really close to passing right through point P. And notice how the line that I made is perpendicular to the original one. It's not a perpendicular bisector. It doesn't split it equally in half. That's a different construction. This is just a perpendicular line to the given line through a given point. And here the given point was point P, so it should end up coming really close to going right through point P. Okay, question number 7. So question number 7 says, write all the statements that are true based on the diagram's markings. So based on the diagram's markings, I'm going to start with the first one up here. So I know that angle W is a right angle. I know that perpendicular lines form right angles, so I know that XW is perpendicular to WV, because if they form that right angle, then that means they are perpendicular to each other. I know that angle S, or angle UST to get more specific, is congruent to angle T, or angle UTS to be more specific. And that's because they have congruence marks on them. I know that line XV is parallel to line UT, and that's because they have the arrows on them, which indicate parallel. There are other statements that you can make. You can say things like angle SUT, this angle over here, is supplementary to the angle next to it, which is true because together they form a 180-degree angle. You can name obtuse angles, you can name acute angles, all true. But I think we have the main point down here, and I'm going to move on. In 8, it says lines AB, here's AB, and CD intersect at point E. If measure of angle AEC is 7x plus 16, and measure of angle BED is 3x plus 48, what is the measurement of angle CEB? So we're looking for this angle. First, I'm going to recognize that the 2 angles I have are formed by intersecting lines. We see the letter X, and they're opposite from each other. They're vertical angles. So they are equal to each other. Subtract 3x on both sides. I have 4x is equal to, I'm going to also subtract 16 on both sides. 48 minus 16 is 32. And then I just need to divide by 4. And I have x is equal to 8. Now I can plug back in to find one of the angle measurements. 7 times 8 is 56. Plus 16 is 72 degrees. These two angles are supplementary. I should use a different color. They're supplementary. They form a 180-degree angle. So 180 minus 72 is 108 degrees. So the angle that we're looking for, which is angle CEB, the measure of that angle is 108 degrees. Moving onward. Find the value of x and the measure of angle BHE. So we're told that we have parallel lines, and we're told that AB is a transversal. We're told that DGH is 2x, and we're told that FHB is 5x minus 51, and we need to find BHE. So we're looking for this angle in red. First, I'm going to think about the relationship between the two angles I have. Here, I have my parallel lines and my transversal. And notice how these two angles are in the same position. We have bottom right and bottom right. That means the corresponding angles. And since we have parallel lines, corresponding angles are congruent to each other. Subtracting 5x from both sides, I have negative 3x is equal to negative 51. I'm going to divide by negative 3 on both sides. So negative 51 divided by negative 3 is positive 17. So the x value here is 17. And the measurement of angle BHE, first we need to find the angle next to it. So let me do 17 times 5 minus 5. And I got 80. So that makes the angle that it's supplementary with 100, because these two angles are supplementary to each other. So I found 100 degrees here. Okay, for the next one, we're going to be constructing a parallel line. That's what I was starting to do before. So we need a transversal. You should make it a little bit slanted, as I was starting to talk about earlier in the video, and I thought that was the earlier question, but that was the perpendicular line one. We're going to be copying an angle to create congruent corresponding angles. So put your compass on the vertex of the angle that you're copying. Open up a little bit. It doesn't matter how much. You just need to be on the angle. And then we're going to go up to point C. And we're going to make the exact same arc. Now that we have that first arc here and here, we're going to actually measure the angle so we can copy it. So we're going to measure between those two intersection points. And remember that after you match up your compass from point to point as best as you can, and if you're using a flat compass, you're finding the hole that best matches up. Oops, these things always pop up. I'm trying to search the color. You're going to put a little arc to show that you measured, because people only know that you measured if you show it with an arc. And then we're not going to go here, not point C. We're going to go here. And we just need to intersect that first arc, and we're all done. That's it. Through that intersection point, oops, is where I'm going to attempt on the computer to use my straight edge, which is very, very difficult. See, I'm completely missing it. Let me start from here. Lines are infinite. It doesn't matter. Look, it's parallel. Awesome. Comes really close to passing right through the point. That is so much easier to do on paper. But as you can see, my lines are parallel, and they're parallel because we've created these congruent corresponding angles with our construction. And then finally, moving down over here, We always start with our givens. We're going to just put that in right away. So that's angle 1 is congruent to angle 3. I want to also make sure I mark the givens in the diagram. Do not try to do these without marking the diagram. You will not get it right. Do not do that, especially when things get more complicated. Please mark the diagram. Take a look at your givens. Mark them in your diagram. Think about conclusions you can draw before you move on. Okay, so I marked angle 1 congruent to angle 3. My next given, oh, I almost made a mistake. There's 2 givens here. I need to put this here as well. Ray CE bisects angle DCB. So the choice is yours when you're writing your own proof, whether you want to put the givens in the same step or break them up into 2 separate steps. Here, it's a fill in the blank proof, so you have to follow the logic of the fill in the blank proof. And here, since there's only, I'm assuming, 1 step for given, because this is filled in, that's not the given. This has a reason and it's not given, and this has a statement and it's not given, and it's also the end of the proof. They both have to go here. It's the only spot for them, so that's given. Let's take a look at what conclusions we can draw from that second given. So we're told that CE bisects angle DCB. So angle DCB is being bisected by this angle bisector. And we know that angle bisectors split angles into 2 congruent parts. So the 2 congruent parts would be angle 3 and angle 4, because the angle that's being bisected is DCB. It's being bisected by ray CE. So notice how this is the bisector, so it's cutting this angle equally in half. And I see that here. That's number 2. Now that we thought about it and we marked it in the diagram, we see that conclusion for ourselves. We're not just trying to figure out where this came from. We see it now. And now we can put our reason in our statement reason chart. An angle bisector splits an angle into 2 congruent parts. So let's take a look at what we can conclude from here. We have angle 1 congruent to angle 3. That was from the, and now we just showed from the angle bisector that angle 3 was congruent to angle 4. So notice how angle 1 and angle 4 are both congruent to the same angle 3. So that means they're going to have to be congruent to each other. And that's the transitive property. When 2 things are congruent to the same third thing, so that means they have to be congruent to each other. And I see that here, the transitive property. And our conclusion, or our statement, that goes along with the reason is angle 1 is congruent to angle 4. Once again, angle 1 and angle 4 are both congruent to the same angle 3. So that means they have to be congruent to each other. And we can see that as well in the diagram. Angle 1 and angle 3 are congruent, so are 4 and 3. So angle 1 needs to be congruent to angle 4. Okay, so now that we know angle 1 is congruent to angle 4, let me make sure I have them both in the same color so it's easier to see here. It's saying that the lines are parallel. I can only prove lines parallel with an angle relationship, right? When that's true, when the lines are parallel. So like, for example, congruent corresponding angles, congruent alternate interior angles, or supplementary same side interior angles. It has to be something with angles. So let's take a look at what the relationship is between angle 4 and angle 1, because that's what we just proved. So that's probably going to lead us into our reason for why the lines are parallel. Here are my lines. And here's my transversal. Well, I should say a transversal. Let's think about what kind of angles these are. We have top right, and we have top right. These are corresponding angles. So I'm going to put here, if corresponding angles are congruent, then lines are parallel. And that's the end of the review sheet. Let me go back down to that. Oops. And that is all.